In this video, we will practice solving rational inequalities. This is AP Precalculus topic 1.8. Again, this is a practice video. If you did not see the previous video where I introduced all of these concepts, you should probably watch that first. This video will make a lot more sense if you do. You can either click the link that appears in the upper right-hand corner or find the link in the description. If you appreciate this content, please don't forget to hit that like button. These next four problems will require some factoring first. X squared minus 9 is the difference of two squares, which factors as x plus 3 times x minus 3. So now we have this. Where does f of x equal 0? That's at x equals negative 3 and x equals positive 3, where the numerator is equal to 0. Where is f of x undefined? That's where the denominator is equal to 0, which is at x equals negative 2. Set up your sign chart like this. The x plus 3 gave us the negative 3. This factor is negative on the left, positive on the right. The x minus 3 gave us the positive 3. It will be negative to the left and positive to the right. X plus 2 gave us the negative 2. It will be negative to the left and positive to the right. F of x will be negative in the first interval because of the odd number of negatives, positive in the second interval because of the even number of negatives, negative in the third interval, and positive in the fourth interval. We are looking for where f of x is greater than 0. That's going to be where f of x is positive. Should we include any of these endpoints? No. We are not interested in the values where f of x is equal to 0 or undefined, only greater than 0. So we will show that the endpoints are not included by using parentheses like this. So this first interval goes from negative 3 to negative 2, all parentheses, union, and the second interval goes from 3 to infinity. We need to factor number 17 before we get started. X squared will only factor as x times x. 10 can either be 2 times 5 or 1 times 10. I'm betting on 2 times 5. Inner plus outer must equal middle. So to get a negative 3, I'm going to need a positive 2 inner and a negative 5 outer. So we factored it. F of x will equal 0 when the numerator equals 0. That's at x equals negative 2 and x equals positive 5. F of x will be undefined wherever the denominator is equal to 0. That's at x equals negative 8. Set up your sign chart like this. X plus 2 gave us the negative 2. It'll be negative to the left, positive to the right. X minus 5 gave us the 5. Negative to the left, positive to the right. X plus 8 gave us the negative 8. Negative to the left, positive to the right. Look at the odd number of negative signs. F of x will be negative in this interval, positive in the next interval, negative in this interval, positive in this interval. We are looking for where f of x is less than 0. In other words, where f of x is negative. We will not include any of these endpoints because we are not interested in where f of x is equal to 0 or where it's undefined, only less than 0. We will show that the endpoints are not included by using parentheses around them. So this first interval is from negative infinity to negative 8, and then union negative 2 to 5. let us factor number 18. X squared plus 1 does not factor. The sum of two squares is unfactorable. So we will just leave this as x squared plus 1. But this trinomial will factor. X squared will factor as x times x. 9 will either factor as 3 times 3 or 1 times 9. Let's go with 3 times 3. Inner plus outer must equal the middle. So I need negative 3x and another negative 3x to make negative 6. Also, negative 3 times negative 3 is positive 9. Now that I notice that this factor is repeated twice, I would rather rewrite this as x minus 3 quantity squared. F of x will equal 0 where the numerator is equal to 0. That's going to be at x equals 3. F of x will be undefined where the denominator is equal to 0. But the denominator will never equal 0. When you square something, it's always going to be positive. Or at the very least, it's going to be 0. It'll be greater than or equal to 0. So if you take something that's 0 or greater, and then you add 1 to it, it's always going to be positive. So this expression can never be anything less than positive 1. So it'll never be 0, it will never be undefined. So, sign chart. Set up your sign chart like this. X minus 3 squared will be positive in both of these intervals because when you square even a negative, it becomes positive. We already discussed why x squared plus 1 will always be positive. So that means f of x will be positive in both of these intervals. Does that mean that the solution is going to be negative infinity to positive infinity? Nope. That would accidentally include the 3. And 3 is where f of x equals 0. We only want where f of x is greater than 0. If this had been greater than or equal to, then the answer would be negative infinity to positive infinity. But it's not. So we need to write two separate intervals. Negative infinity to 3, parenthesis, and then union 3 to infinity. Alright, that's all real numbers except for 3. Let's do one more of these and then we are going to switch gears. (3x squared). Actually, let me slow down a little bit. Students have trouble factoring things like this, a trinomial that has a number other than 1 in the front. So watch this very carefully. 3x squared will factor as 3x times x. Alright, I always just start with that first term. Now I'm going to skip the middle for now. Looking at the 8. 8 can either factor as 2 times 4 or 1 times 8. Right now I don't know which one it's going to be. I always start with the numbers that are closer together though. So I'm going to start with 2 times 4. Inner plus outer must equal the middle. Right now, inner is 2x. Outer is 12. That's really big. Too big. I can control the signs, but there's no way I'm going to pick the signs on 2x and 12x that's going to give me a middle of negative 2x. So let's try switching the 2 and the 4. Inner plus outer equals middle. Inner is now 4x. Outer is now 6x. This is looking much better. To get a middle of negative 2x, I need a positive 4x and a negative 6x. So that means a positive here for the positive 4x and a negative here to make a negative 6 outer. Also, positive 4 times negative 2 is negative 8. F of x will equal 0 where the numerator is equal to 0. So that's going to be x equals negative 4 over 3 and x equals positive 2. F of x will be undefined where the denominator is equal to 0. So that's going to be at x equals negative 1. Set up your sign chart like this. 3x plus 4 gave us the 0 of negative 4 over 3. It will be negative to the left, positive to the right. X minus 2 gave us the 2. It will be negative to the left, positive to the right. X plus 1 gave us the negative 1. It will be negative to the left, positive to the right. F of x will be negative in the first interval because of the odd number of negatives, and it will be positive in the next interval, negative and positive. We are looking for where f of x is less than or equal to 0. So the solutions will be in the intervals where f of x is negative. Because we want the values that will cause f of x to be less than or equal to 0, we should include these two values where f of x is equal to 0. And we will show that when it is solution time using brackets. So I'm going to put them down now so I don't forget. So I'm going to have a bracket on the negative 4 over 3, and I will have a bracket on the 2. But I will have a parenthesis on the negative 1 because we still don't want to include any values where f of x is undefined. So this first interval is from negative infinity to negative 4 over 3, bracket, union, negative 1 to 2, bracket. Take out your TI-84 for number 20. Copy this function r of x in as y1. The rational function r is given by r of x equals this expression. For what values of x does r of x equal 0? So we are being asked to find the zeros of r. That will show up on the graph as x-intercepts. So let's graph it. To start off with a standard 10 by 10 window, let's hit zoom 6. From this distance, it looks like there will be 3 x-intercepts. There seems to be one here, and one here. This little jag right here is probably a vertical asymptote. But let's zoom in a little bit more. What would be fun is zoom box. Let's check that out. Zoom box, that's zoom 1. Try it. Move your pointer to the upper left-hand corner of your area of interest. So I'm going to move it to about here. And hit enter. Now move your pointer to the lower right-hand corner of your area of interest. You'll notice that as I move, it is drawing a rectangle. And when I hit enter, it will zoom in on whatever is inside the rectangle. Alright, this gives me a much better view that I'm going to have a 0 here, here, and here. These two are really close together. So there are two ways to find zeros. My least favorite way is to do second trace 0. That puts you through a left-bound, right-bound situation. I don't like that. So my favorite way of finding zeros is to graph the x-axis itself. So I'm going to put 0 right here, and I'm going to go back to my graph. See, that red line is the x-axis. Now I can just find the intersection between the blue and the red, and those will be my zeros. So let's hit second trace, intersect, second trace 5. Now we can just move the pointer close to each one of these zeros. I think I'm going to go in order from left to right. So I used my up arrow to jump to the red, just because I can see that that's going to be a smooth trip from left to right. So just come over here near the first 0 and hit enter 3 times. Enter, enter, enter. So my first 0 is at negative 2.303. So you can see we are on the right track. We can eliminate option B so far. Let's go after this middle 0 now. So let's hit second, trace, intersect again. Move that pointer close to that middle 0. Whoa, I went too far. And just hit enter 3 times. Enter, enter, enter. Oh, this is exactly 1. I started to say we can't eliminate anymore, but we can eliminate D because there was only one negative 0, negative 2.303. There was no negative 1.643. So we can eliminate D. In fact, to be honest, we already know that the answer is going to be C, because we do see that there are 3 zeros. Not 2, not 4, but 3. So we know C is going to be the answer. Let's follow through and find the 1.303, just for fun. One more time. Second, trace, 5. Okay, I'm moving to the red for easy travels. Okay, move over close to this guy and hit enter 3 times. Enter, enter, enter. There it is, 1.303. 21. The rational function g is given by g of x is equal to all of this. For what input values of g are the output values of g equal to 0? This is just a funny way of asking for the zeros of this rational function. The zeros will be where the numerator is equal to 0. So we have some factoring to do. Looking at this first factor, there is a common factor of x. So let's start by factoring that out. So that's going to leave behind x plus 3. Now for this trinomial, this will surely factor as a binomial times a binomial. X squared will factor as x times x. 5 will only factor as 1 times 5. Inner plus outer must equal the middle. To get a negative 4, I'm going to need a positive 1x and a negative 5x. So I have factored it. So I carelessly said that the zeros of this function will be where the numerator is equal to 0. And that's usually true, but I have to be a little bit more careful than that. So if I went by just that, this is too big. If I went by only that, then I would say g of x is equal to 0 at x equals 0 and x equals negative 3 and x equals negative 1 and x equals positive 5. But there's a problem with one of these. Does anybody see the issue? Well, the key is the fact that one of these factors appears in the numerator and the denominator. This x plus 3 here shows up in both places. This is no good in terms of the zeros of this function, because g of x is undefined at x equals negative 3, because that would cause a 0 in the denominator. It would cause a 0 in the numerator and the denominator, but that's still undefined. So this one has to be thrown out. So this will not be included among the zeros. So it will just be -1, 0, and 5. So the answer is B. Last one. Number 22. The rational function r is given by r of x equals this expression. On what intervals of x is r of x greater than or equal to 0? Alright, this is just like the many problems that we did up here. But first we have some factoring to do. Every term in the numerator has an x in it. So let's start by factoring out the x. So that's going to leave behind x squared plus 4x plus 4. Over x squared minus 9. And we are looking for where r of x is greater than or equal to 0. This will factor further. This trinomial will surely factor as a binomial times a binomial. Greater than or equal to 0. X squared will factor as x times x. 4 will factor as 2 times 2, or 1 times 4. But the inner plus the outer must equal the middle. So 2x and 2x make 4x. So we factored it. Also, the denominator will factor. This is the difference of two squares. So x plus 3 times x minus 3. Now that I look at it, I see that the x plus 2 appears twice. So let's write this as x plus 2 quantity squared. Like this. Where will f of x equal 0? That's going to be where the numerator is equal to 0. So that's going to be at x equals 0 and x equals -2. Where will f of x be undefined? That's going to be at x equals -3. And if I can squeeze it in here, x equals +3. I should have said r of x here, not f of x, and put r of x right here as well. We will need 4 rows because we have 4 separate factors. We need a row for x, a row for x plus 2 squared, a row for x plus 3, and a row for x minus 3. Put these critical values, oh, whoops, I'm missing one. Am I not? See if I can squeeze it on here. Put your 4 critical values across the top in order from least to greatest. So we're going to start with this -3, and then we have -2, and then 0, and then +3. The x will obviously be negative to the left of 0 and positive to the right. X plus 2 squared will be positive in every interval because when you square even a negative number, it becomes positive. X plus 3 gave us the 0 of -3. This factor is negative to the left and positive to the right. X minus 3 gave us a 0 of +3. It will be negative to the left and positive to the right. We have an odd number of negatives in the first interval, so r of x will be negative here. Even number of negatives, r of x is positive here. R of x is also positive here, negative here, and positive here. We are looking for the intervals where r of x is greater than or equal to 0. So the solutions will be where r of x is positive. Okay, that's going to be in these intervals. But also where it is equal to 0. So that's going to include this -2, which is right in the middle of two other intervals. Because of that, this will just be one fat interval because of the or equal to. We also want to include the 0 endpoint. So I'm going to show that with a bracket right now. We will not include the -3 or the 3 because r of x is undefined at those values. So I'm going to leave that as parentheses. So in interval notation, we have two intervals. We have an interval from -3 to 0. Okay, parenthesis, bracket, union, and then we have another interval from 3 to infinity. This will be slightly tricky because this is multiple choice and they did not give us the answers in interval notation. But let's see if we can match it up. So -3 to 0, that's right here. We see the less than, that's parentheses, and you see the or equal to on the 0, that's the bracket. So this is matching up great. And the inequality x is greater than 3 matches the interval from 3 to infinity. So the answer is D. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.